All right, welcome back to another episode of Composites Weekly. Today, I have two gentlemen joining me on the show to talk about their unique technology and innovative technology they've developed for industrial mixing. These guys are a global leader in industrial mixing and processing solutions. The company is Resodyn Corporation, or Resodyn Acoustic Mixers. Mixing is a key processing step in nearly every industry, from lubricants to ceramics. Traditionally, mixing has been accomplished by using motor-driven impellers, blades, and other engineered devices that rotate and otherwise agitate the ingredients. These methods, however, present several challenges, including non-uniform and inconsistent mix quality, and also extended mixing times. Fortunately, their new and innovative technology solves many of the problems that plague traditional mixers. Their RAM technology combines the efficient power generation of resonance and the effects of sound energy to facilitate mixing without the use of impellers or mechanical means. And today we're going to be discussing some of their commercial successes with their technology, their acoustic mixers. I have Mark Scott and Jake Rowen of Resodyn Acoustic Mixers on the show today, or Resodyn Corporation on the show today. And gentlemen, thank you so much. I'm opening up your mic. Thank you for joining me on the program today. Let's get started about the background, if you would, and I'll let you guys just kind of speak freely. Whoever wants to answer on these questions, but let's start with the background of Resodyn. Tell us a little bit about the history of the company.
Yeah, so Resodyn was founded in 1994 in Butte, Montana by Larry Farrar. In 2004, the first resonant acoustic mixing, or RAM, device called the Army RAM was developed for the U.S. Army Redstone Arsenal in Alabama. And the Army RAM was funded by an SBIR, or Small Business Innovation Research grant, for use in developing gelled propellants in the energetics industry. In January 2005, a separate business entity called Resodyn Acoustic Mixers was launched to focus on the sales and marketing of the RAM technology. And in 2005, our first mixer was launched, called the Lab RAM Mixer. And in the years since, products have been introduced to scale up from the benchtop through pilot all the way to production scale. We've customized our technologies for industries like pharmaceuticals, hazardous materials in the energetic space with our H series. We've also added different accessories like the jacketed vessel for temperature control. We also have integrated vacuum systems for degassing materials. And we have drastically evolved to include continuous mixing capabilities to increase our production of our technology. And we're also currently developing a continuous acoustic chemical reactor and continuous acoustic crystallizer.
It's fascinating just reading about it. It's so interesting. Give us an overview of how this process works.
Absolutely. So the RAM, it stands for resonant acoustic mixing, and we use resonance to basically do work on material. And many people have had a reintroduction to resonance in physics, either in high school or college. But just about everyone has a much earlier memory. It started when they were a child on a swing set. Each child learns very quickly that if they shift their weight, kick their legs, lean forward and back at the right time, they can make the swing go higher. And they're reminded of this as an adult as well, when they're pushing their child on a swing, or growing up with a little brother or sister or friend. And in this case, they are what we calling the forcing function, which is pushing at exactly the appropriate time to make it go higher or maintain the energy. And, we operate our RAM mixer at the resonant frequency because basically it's, minimal input for maximum output. So it's a very high efficiency machine. And so you can almost think of the RAM technology like that swing example. The resonant frequency of the swing is determined by the length of the swing and the weight of the person. On our equipment, the resonant frequency is set by the strength of the spring, called the spring constant, and the weight or mass of the material being mixed. So just like the person pushing the swing, we can use acoustic drivers or voice coils to apply force to exactly the right moments to create movement at precisely the resonant frequency, which is nominally 60 hertz. Now the mass remains constant, but as the materials are mixed, properties can change and change the damping force. So the RAM equipment, it's got software basically to maintain that resonant frequency during the mixing cycle to ensure maximum performance. And kind of that, the swing set example is just kind of one of the simplest answers we know.
Yeah,
The
that makes sense.
Composites Weekly audience is made up of some highly technical people, and many of them have probably had much exposure to resonance in their education or career.
Yeah.
Most of the time they're designing systems to avoid resonance, but we're designing equipment to kind of harness that power of resonance to do work on material.
So we talked about, like, in the introduction, some of the challenges with traditional mixing, degradation, and you don't, not always getting a uniform mix, consistency in the mix, long extended times. Let's highlight some of the benefits that you see over traditional mixing outside of that.
Yeah, so I mean, a lot of challenges that I see personally, when clients are using like high shear blade mixing technologies, they can run into issues as far as cleanup. There's complex blade configurations with highly viscous materials. Oftentimes they have sidewall scrapers. And, at the end of the day, you have to take these machines apart and clean them up. Whereas with our style of mixing, we're non-contact, so we're just mixing directly in a vessel. There's no blades, engineered devices, or probes inside. So cleanup is pretty simple and straightforward.
What is the time comparison between this and RAM mixing?
Yes. So oftentimes it's 10 to 100 times faster than traditional mixing technologies. It's pretty incredible what we've done with some clients. I have some customers where, they're mixing materials for 8 to 10 hours at a time, and we're able to complete that process, sometimes in 5 minutes or 10 minutes or even a couple minutes too. Basically we apply a uniform shear field throughout the mixing container. So we just rapidly fluidize all the material inside of the container. Whereas when you're mixing by blade, oftentimes those mixing zones are localized just around your blade, and material kind of has to travel through the blades. It kind of goes back up to the fluid surface level, back through the blades, where we're just basically a uniform shear field throughout the material inside of that container. So we do see rapid mixing times.
What are some applications within our industry? There's a lot of, resin formulators and can you highlight maybe some specific industry segments of our industry that are benefiting from this technology?
Sure. Yeah. So oftentimes in our experience with, people in the composites industry, they have a viscous resin, and they want to, uniformly distribute various filler powders into that material.
Yep.
And that resin, it's usually highly viscous. It's a bugger to handle it. Even putting it into the material, oftentimes you have to heat it up at an elevated temperature to do adequate mixing. And
we create these Faraday instabilities in the material that really enable the mixing. These are something that are nonlinear waves. They appear in liquids due to the high amplitude and periodic driving force. And under the proper conditions, especially with these highly viscous materials, the flat surface of the liquid will become unstable. And our technology is the first one to really harness the Faraday instabilities and put them to use. They were discovered in the 1800s, but we put them to useful work. And not only are we the first, we pretty much remain the only one to do it. And it's something, to your point, that occurs not just in liquid-liquid mixes, but also in liquid-solid mixes.
Right.
And we have a mixture of corn syrup and powdered sugar and blue sand that can exhibit some of that kind of phenomenon.
Certainly. Yeah, we'll show you how that looks on the machine. This is our LabRam 1 that can do up to 500 grams of material. And I mean, just to get an idea how this mixer works is, we have our spring mass system here. And then we basically have a mechanical vibrating system that we attach your mixing vessel to with a clamp. So your vessel, it oscillates at about a ½ inch, 60 times a second. So here we'll show an example of a paste. This is corn syrup. It's got a viscosity around 2100 centipoise. And then we'll add a powdered sugar.
There we go.
And then we'll add a blue sand. So we have two powders of different size, different density. And then we're going to be running the machine without the lid closed, just so we have a good view of it on the cam.
Right.
But usually this door has to be closed for the machine to operate. And so we'll run this at an acceleration of 80 Gs. We can control the acceleration of the oscillation from 0 to 100 Gs, or times the force of gravity. So we'll be at 80 Gs for 2 minutes. And we'll hit start.
That's wow.
So that was 2 minutes of mixing.
2 minutes of mixing.
Yep. And this is about a 350,000 centipoise paste. I think one thing to note that's pretty important is, I'm touching this right now. I've done this mix many times. The temperature rise in this mix after 2 minutes is only around 1 to 2 degrees Celsius. And I do think that's an important thing we should, note, is that the heat generation in viscous materials with this technology is really slow, and much slower than traditional blade mixing technologies, or even dual asymmetrical centrifuge style of mixing as well.
So what's tell us what is that centipoise again, with the viscosity?
Yeah, so it's around 350,000 centipoise.
Okay.
You kind of get a good look there. It's pretty thick, sticky. And, you imagine mixing this with a blade, you can see all the material stuck to the tongue depressor. There's a lot of cleanup involved with different blade configurations.
Right. And that took all of 2 minutes.
Yep, 2 minutes.
So you're standing, that is in front of that looks like the Lab Ram 1 mixer.
Yep, that's correct. Yeah, this is our Lab Ram 1. It can do up to 500 grams of material at a time. It can be used for that thick paste that we just showed. It can also be used to blend powders as well. And even for other applications too.
Right. And larger scale mixers. I mean, what are your capabilities in terms of large scale mixing?
Yeah, so we have the Lab Ram 1 that can do 500 grams. The Lab Ram 2 behind Mark can do up to 1 kilogram of material. And then moving up, we have the Omni Ram that can do up to 5 kilograms. The Ram 5 can do up to 36 kilos, and the Ram 55 can do up to 420 kilograms. And those are our batch units. The Omni Ram, Ram 5, and Ram 55 can also be configured for continuous operation too, because we understand, the Ram 55 can do a 55-gallon drum size nominally, or up to 419 kilos, and for a lot of big production, that's not suitable. So we have continuous capabilities to mix material continuously, all on the same platform, to increase our production throughput. And one thing that's pretty unique about this technology is, we generate the same acoustic environment at this small, pint-sized scale that we would at our larger production scale as well. So we typically use the same parameters on this machine as we would when we scale up to our larger machines too.
Right. Anything in aerospace that you all are working on? Or
yeah, absolutely. In aerospace, there's quite a few exciting things going on. We have customers using us for various adhesives, epoxies, and sealants in that area. Another thing that's pretty exciting is for building materials for aerospace parts. We do have one composite client that is making parts with our technology. That's kind of a technical composite. We also have a well-established jet engine manufacturing company that's using RAM for different parts in jet engines. There's also an internationally recognized UK company that's making turbines for jet engines with RAM. And then we also have high-end aerospace material supplier as well. And, a lot of their applications, they're mixing, viscous materials. With the epoxies and adhesives, sometimes those materials are sensitive to heat generation. And that's one area where our technology really excels compared to other ones is with the lower heat generation with the low frequency sound waves that we use. 3D printing has also been pretty big for us lately. NASA, they recently came out with a alloy called GRX 810 that has about double the tensile strength and ductility, and I think it's about 10 to 2,000 times better creep rupture life than conventional super alloys and current 3D printable metal parts. And they're currently using this material in space launch systems, nuclear power plants, and other extreme temperature environments, thanks to RAM. And really how they're using RAM to make this is they're coating various metal alloy powders with ceramic oxides, and they're getting some pretty unique properties when they do that. Pharmaceuticals is one of our biggest industries, and we have many applications in the pharma world. A lot of times when they're blending up powders for tableting, kind of like the ibuprofen or aspirin that's in your home. They want to distribute a really small amount of an active drug into a larger filler powder. And, getting a uniform blend of those materials can sometimes be challenging with traditional style mixers. And, we're one of the best powder mixers in the world, and we can get excellent uniformity in a fraction of the time of traditional technologies. We also,
we actually have a way that saves them quite a bit of money too, is if they pass their first uniformity test with relative standard deviation of 3% or better, then they do their potency test. And if that passes, then they don't have to do a second uniformity test. So we can save the money there. If that relative standard deviation is higher of above 5%, then they fail and they have to do a whole bunch of documentation reporting. If they fall in between those two, they have to do that second level of potency, rather uniformity testing. So even just in the production process, we save them extra testing, extra documentation, and that's money that they can save right off the bat.
And then, also in the energetics industry, it's one of our biggest industries and where we got our start. Really they're mixing sensitive materials that are extremely viscous. And, they were originally using, bladed mixers at a very high torque, low speed, and mix times were often 24 hours to complete a batch of explosives. And, we're kind of a high energy but low shear style of mixing. And, we were able to mix these materials in under 20 minutes. So we save a lot of time for mixing. They've also been able to reduce their solvent usage that is used in cleanup, and, recycling solvents and any of the processes after using solvents are fairly expensive. Another application that's kind of out there is, we're really good at dissolving rubbers and polymers into solvents. And, we have a synthetic rubber manufacturer that has multiple lab RAMs worldwide, where they're using RAM in their QC labs. And so they have these continuous synthetic rubber manufacturing lines. And they take a sample off that line, and then they test it in their QC lab. They basically dissolve the rubber into a solvent. They're using horizontal shakers originally. And it was taking about 6 to 8 hours for them to get a result to kind of gauge the quality on that line. When they switched to RAM, they were able to get a result within 15 minutes. So it's saved them a boatload of money, and also on scrap material too.
Think about the shearing process, and a lot of times you can over shear a product, right? that's a big problem, especially, you get somebody within your facility that's not trained. And I'm sure that's an issue that pops up a lot of times with traditional mixing.
It absolutely is. And, we do have clients that are mixing fragile materials,
Yeah.
and even polymers where, high shear technologies can damage the polymer chains.
Yeah.
We're a low frequency, but high energy, low shear style of mixing. So we actually don't damage polymer chains while mixing
Right.
them. And, when we're blending powders together, we actually don't see any particle size reduction during the mixing cycle.
Wow.
So yeah, which is pretty incredible because, it's something you want to avoid, and it can be difficult when you're using blades to shear material. It's just kind of inevitable that you're going to damage something.
And that's something that we really excel at too, is we will bring customers here with their own materials, and in this facility, have them mix them so that we can optimize things before they purchase, before they take it back to their facility and use it. We also do video demonstrations, not too dissimilar than what we've done here. And of course, we go out to customers on site and take a look at what they're currently doing. And we have people on site that are experts in mixing, and create a mix plan and really optimize for what it is that they're trying to accomplish, and make sure, we talk, I think we've got a situation where we talk about some of the other things that we're capable of doing. And one of them is, in fact, doing milling process that we can, if we go beyond the mix and dial in and optimize that time, we can perform a milling operation. And we're also capable of sieving, where we can shake the material over a plate with different size pores or holes in it to allow certain sizes to pass through and segregate powders by their diameters. And so that's something that the technology is capable of doing as well.
And your facility, you're located up in, I didn't mention this at the beginning, you guys are located, you're headquartered in Butte, Montana. Is that right?
Yep, that is correct. Yeah, we're in the, the western side of Montana, right in the Rocky Mountains.
Yeah.
Butte, Montana. It's a smaller town. We probably have about 35,000 people. But yeah, this is where we're headquartered, and then our manufacturing plant is located right across the street.
Yeah, it's a beautiful area. Where your headquarters, kind of looks like a more traditional or historic building. Is that, what is it? What's the significance of that building?
Yeah, so it's the old Hennessy building. And, Butte, Montana, our county actually has the most historical sites of any area in the United States. Right. This town, back in the late 1800s, early 1900s, was one of the biggest towns in America due to the mining boom, which is primarily copper. And actually, the building that we work in, one of the biggest copper companies, was housed up on the 6th floor where we work. And that was the Anaconda Mining Company. So there's it's rich in history. We're surrounded by mountain ranges, streams, lakes. There's a lot of outdoor activities to do. It is a beautiful place.
And lastly, I want to mention we have the website streaming at the bottom. And I really appreciate your time, gentlemen, but it's resodynmixers.com, where people can learn more. And as you mentioned earlier, you have companies that want to reach out to you, listeners of our show. If they have questions, we've got your website pulled up. There's a contact our experts. Is that typically the best way, to start this, for a discussion? They want to learn more. They should go to your website, learn more, because you can read all about the technology, but if they want to talk to someone, there's contact information there. They can reach out to someone, have a conversation, and then obviously move forward with testing at their facility. Or I'm sure you have people that come up and probably do a walkthrough at your facility up there, just to kind of do a tour of your plant.
Yeah, absolutely. We always welcome customers to come visit us. And we do visit customers too, and complete on-site demonstrations.
Right.
We do recommend contacting us. Our our main number is 406-497-5333. And then our main email is just info@resodyn.com. And those are probably the two best ways to reach us if you have any questions.
And we're also going to be at numerous trade shows this year, Ceramics Expo. We're going to be in Novi, Michigan, the Advanced Materials Show in Birmingham in the United Kingdom. In England, we are having a mechanochemistry conference. So our technology is particularly well suited for mechanochemistry. And there's a center of excellence there led by Professor Tomislav Frisic. Then we'll be at the battery show. I don't know if we've mentioned the battery industry through all of this, but for battery manufacturing and recycling. And then we talked about the pharmacy. We're going to be at the AAPS PharmSci in Salt Lake in October. And then in September, we also host our own technical interchange here. We invite customers and potential customers to come here to Butte, Montana, and learn all about the technology. They can see live and hands-on demonstrations, and that also gives an opportunity for customers to speak amongst themselves and learn from one another.
Gentlemen, I thank you both. And by the way, I have the website pulled up. I got the historic Hennessy building, that page pulled up on your website so people can see. It looks like a really beautiful area. And again, I appreciate you both joining me on the show today. Again, it is our listeners can find out more at resodynmixers.com. If you do a Google search, you probably come up with Resodyn. There's a couple of websites. Make sure it's the Resodyn Mixers and not just resodyn.com. But we'll be highlighting that website on our show page this week. And again, thank you both. It's been fascinating talking about the technology. These mixers serve a global industry, mixing and processing, all sorts of different processes throughout not only our industry, but other industries as well. You talk about, like, as you mentioned earlier, adhesives, ceramics, epoxies, urethanes, all of these applications would be suited. And certainly you want to learn more. You want to go to resodynmixers.com. Mark, Jake, thank you again for the time today.
Thank you, Jonathan.
Yep. Thanks, Jonathan. Really appreciate your time.